In this recording, we'll talk about how to derive labor supply curve given the utility function. Okay, now supposedly if you are given this utility function, U is equal to just this Cobb-Douglas function, C and L. C is the consumption of goods and L is leisure. Small l is leisure. And the budget constraint which you have already seen in our previous recording that budget constraint was C equals to WL. This is W is the wage rate per hour, and L is the amount of labor which is being supplied. Now, so WL becomes the total wage income. Let us add non-wage income also. So this becomes a total income. This is N is the non-wage income. Okay, so adding these two will become the total income. And we have already assumed that the price of consumption is normalized to 1. So what is the total expenditure? Total expenditure is PC into C. But since PC is just 1, so it is 1 into C, which is C here. Clear? And of course, this was your income constraint, and the time constraint is, say, L plus L equals to T. That is, you have T amount of hours which are available to you, and within these T hours, you can either spend these T hours having leisure or labor. Okay, or you can have some convex combination of the two. For example, you have, say, 16 hours as T. So you can spend 8 hours for labor or 8 hours of leisure and so on and so forth. So this is what you have. Okay, from here, remember that this is your time constraint and this is income constraint. Clear? Now, just see this. From time constraint, you can write your L as T minus L. Okay. And C you can definitely write as WL plus N. So in case if you substitute all of this back into the utility function, in place of C you can write WL plus N. And in place of small l you can write T minus L. This is what you can write. Is that right? So simplifying this, what you will be getting is, it will be WLT minus WL square plus NT minus NL. This is what you have. Fine. So in case you find out what is WU by WL, okay, see, L is the only thing in this which is endogenous. So in this case, what will you have? WT minus 2WL minus N equals to 0. So this will give you the critical points. Fine. So which is WT minus N equals to 2WL, or L equals to WT minus N upon 2W, or you can write L as equal to L as equal to T by 2 minus N by TW. So as you could see that this L, which is the labor which is supplied, is dependent upon W and it is dependent upon N, which you have. Okay, and you also think about it. Okay, this is W. So you also think about it. The labor supply curve, it has to be dependent upon the wage rates and the income which you have. Okay, think about it. Of course, what does the supply of the commodity depends upon? The price. Okay, in case if the price is more, you'll supply more. And in case of labor supply also, in case of the wages are more, you probably will supply more. And in case if you already have non-wage income more, then it depends, okay, how much you want to supply already. So this there. So on the assumption that leisure is a normal good, so let us assume this, that let me just put this, okay, so assuming that leisure is a normal good, fine. So what you can say, in case if the non-labor income will increase, then the sign of this derivative del L by del N would be negative, okay, because an increase in N will increase the demand for, sorry, this is del L by del N. Yes, of course it'll be negative. Okay, so what will happen is that since leisure is a normal good, what will happen? N is your income. When income will increase, okay, so demand for leisure will increase, fine, and demand for labor will fall. This L is labor. So del L by del N is negative. But in case if you look at, in case if del L by del N is negative, then it means that the amount of time which you're spending on leisure is increasing. Okay, so that is being said. So in case if leisure is assumed to be a normal commodity, the del L by del N curve, this will be negative. Is that right? Okay.